Hello everyone, welcome to our channel Ask Prep. In today's series on 11th grade chemistry, we will be studying chapter 7, Equilibrium, in detail. Let's start the video. Starting with chemical equilibrium. In a chemical reaction, chemical equilibrium is defined as the state at which there is no further change in the concentration of reactants and products. At equilibrium, the rate of the forward reaction is equal to the rate of the backward reaction. Next is equilibrium mixture. The mixture of reactants and products in the equilibrium state is called an equilibrium mixture. Based on the extent to which reactions proceed to reach the state of equilibrium, these may be classified into three groups. The reactions that proceed almost to completion, leaving negligible concentrations of the reactants. The reactions in which most of the reactants remain unchanged. That is, only small amounts of products are formed. The reactions in which the concentrations of both reactants and products are comparable when the system is in equilibrium. Equilibrium involving dissolution of solid in liquid. When a limited amount of salt, sugar, or any solute dissolves in a given amount of water, a solution is formed. At a given temperature, when no more solute can be dissolved, the solution is called a saturated solution. The equilibrium between a solid and its solution is indicated by the saturated solution and can be represented as follows. Dissolution and precipitation occur at the same rate. Adding a small amount of radioactive sugar to the saturated solution shows that the sugar present in both the solution and the solid state is radioactive. Henry's law. The solubility of a gas in a liquid at a certain temperature is governed by Henry's law, which states that the mass of a gas that dissolves in a given mass of a solvent at any temperature is proportional to the pressure of the gas above the surface of the solvent. Next is equilibrium in chemical processes. Like equilibria in physical systems, equilibrium can also be achieved in chemical processes involving reversible chemical reactions carried out in a closed container. The dynamic nature of chemical equilibrium can be demonstrated by the synthesis of ammonia in Haber's process. Haber started his experiment with known amounts of N2 and H2 at high temperature and pressure. At regular intervals, he determined the amount of ammonia present and the concentrations of unreacted N2 and H2. After a certain time, he observed that the composition of the mixture remained the same, indicating the attainment of equilibrium. Law of chemical equilibrium. At a constant temperature, the rate of a chemical reaction is directly proportional to the product of the molar concentrations of the reactants, each raised to a power equal to the corresponding stoichiometric coefficients as represented by the balanced chemical equation. Next is relationship between equilibrium, constant K, reaction quotient Q, and Gibbs energy G. A mathematical expression of the thermodynamic view of equilibrium can be described by the equation. Factors affecting equilibria. Le Chatelier's principle. If a system at equilibrium is subjected to a change in temperature, pressure, or concentration, the equilibrium shifts in a manner that counteracts the effect of the change. Effect of change in concentration. When the concentration of any reactant or product in a reaction at equilibrium is changed, the equilibrium composition shifts to minimize the effect. Effect of pressure change. If the number of moles of gaseous reactants and products are equal, there is no effect of pressure. When the total number of moles of gaseous reactants and products differs, increasing the pressure will cause the equilibrium to shift toward the side with fewer moles of gas. Effect of inert gas addition. If the volume remains constant, adding an inert gas does not affect the equilibrium. Reason. This is because The addition of an inert gas at constant volume does not change the partial pressure or molar concentration of the reacting species. The reaction quotient changes only if the added gas is involved in the reaction. Effect of temperature change. When the temperature of the system is changed, increased or decreased, the equilibrium shifts in the opposite direction to neutralize the effect of the change. Next is Arrhenius' concept of acids and bases. Acids. According to Arrhenius' theory, acids are substances that dissociate in water to give hydrogen ions H plus AQ. Bases. Bases are substances that produce hydroxide ions OH minus AQ after dissociation in water. Lewis acids and bases. According to Lewis, an acid is a substance that accepts an electron pair, while a base is a substance that donates an electron pair. Electron deficient species like aluminum chloride, LCl3, BH3, and H can act as Lewis's acids, while species like H2O and NH3, which can donate a pair of electrons, can act as Lewis bases. Next is ionization of acids and bases. The strength of an acid or base is determined by the extent of ionization in an aqueous solution. pH scale. Hydrogen ion concentration is measured in terms of pH, which is the logarithm of the reciprocal of the hydrogen ion concentration. Common ion effect. When a strong electrolyte containing an ion common with a weak electrolyte is added to an aqueous solution of the weak electrolyte, the dissociation of the weak electrolyte is decreased or suppressed. This phenomenon is known as the common ion effect. Equilibrium. Equilibrium can be established in both physical and chemical processes. At equilibrium, the rates of the forward and backward reactions are equal, denoted by K. Equilibrium constant, Kc. Kc is expressed as the concentration of the products divided by the concentration of the reactants, with each term raised to the power of the stoichiometric coefficients. Thank you for watching. We will be dropping notes in the description of this video. If you found this video helpful, kindly like, subscribe, and share. See you in the next video. All the best for your exams.